Let's begin our unit on extending to three dimensions. We're going to take a look today at three-dimensional figures, such as a prism, a sphere. We'll talk about cones. We'll also talk about pyramids, all those good three-dimensional figures. We'll also talk about how to find what their cross-sections are. And cross-sections will help us as we start to figure out volumes and surface areas, help us start to really understand solid figures. So before we get started talking about that, let's get some terminology down, some definitions about what makes a solid figure and what makes it a polyhedron, what makes it not a polyhedron. So here's our list of figures that are polyhedron, or polyhedrons, I should say, plural, polyhedra, and these are not polyhedra. So can you figure out what makes, what's the difference between the two? If you're unsure, take a look at the definition down here. A polyhedron is a solid bounded by polygons. So these are all polygons, all their faces. Whereas on the cylinder, or cone, or sphere, they're not polygons. For instance, the sphere here, it's got rounded, curved edges. Remember, polygons don't have rounded sides. So we call the faces the flat region that encloses the space. So we have faces on the front, top, bottom side, and the edges are the line segments formed by the intersections of those faces, and the vertex, or the vertice, is where all those edges meet. So we can see all those different spots. Oops, get it in the camera here, where those meet. So that is a definition of what is a polyhedron. So let's now get into identifying these, naming these, and identifying number of faces, vertices, and edges. So as we do that, let's just take a look at this first one. This first one we would call a prism. If the base is the same shape, think of it as, you've played with Play-Doh before, right? So if you take the Play-Doh and you squeeze it through a rectangular shaped hole, out is going to come a rectangular prism. And if you would have had a triangular shaped hole, we would have a triangular prism. But we've got rectangle slices the whole way through in this rectangular prism. The next figure we would call a pyramid. It starts off with this base. The base shape is a hexagon, so we'd call this a hexagonal pyramid. Pyramids are different from prisms in that they all go up to one point. They don't maintain their same shape all the way through. And then the next one is not a polyhedron, but we call this one a cone. It's not a polyhedron, remember, because it's not made of polygons. This circle is its base shape, and it then goes down to a point, but it is not a polyhedron. Next, let's talk about the number of faces, vertices, and edges. So see if you can count how many faces on the rectangular prism. So we've got a front, a back, a top, and a bottom side. We have also got the left and the right. So we've got 6 faces. And then as we talk about the vertices, those are all the points. So you can see I've got trying to get my fingers on all the points here. We've got the 4 points in the corners. And then those 4 are the only 4. Then we got 4 in the back. So you've got 8 total vertices. And then as we take a look at the edges, I've got, look at the front here, 1, 2, 3, 4 across the front. 1, 2, 3, and 4 along the sides. And we flip it over, we've got 4 more on the back side. So a total of 12 edges there. So see if you can visualize those for the hexagonal pyramid and calculate the number of faces, vertices, and edges. And the cone, we don't classify faces, vertices, and edges since it's not a polyhedron. We can't classify faces because there aren't any polygons on there. So pause the video and see if you can count the number of faces, vertices, and edges for the hexagonal pyramid. Restart it when you're ready. All right, so you should have gotten 7 faces because you have 1 on the bottom, 1, 2, 3, 4, 5, 6 around the side, 7 vertices, 6 on the bottom and 1 at the very top, and 12 edges, 6 on the bottom and 6 going up. So next, let's see if we can find a pattern. And here's where I'm going to have you try some of this on your own. So here's a website that's found on Classroom and on the website that will help us explore the connection between faces, vertices, and edges as we go through the different shapes. So let's start off with the triangular pyramid. I can click play to take a look at the net and see how it's folded together. We call it a net when we take all the faces and unfold it. So if we do that, we can take it at any point and pause it so that we can take a look at the faces. When it's unfolded, we can see that there are 4 faces, and when we fold it all back together, we can see that there are 1, 2, 3, 4 vertices. Oops. And the number of edges, we can count them up, 1, 2, 3 on the bottom and 3 going up the sides. That would be 6. So why don't you take the time, I'm just going to pause this here and we'll go back to the notes, but see if you can find the connection. Go through all the different shapes. So next I'll click on the cube, go through the different shapes, calculate faces, vertices, and edges, go through all those until you sense a pattern. And when we get back in the notes on the video, we'll take a look at that pattern and write an equation for it. So pause the video now and work through this on your own and restart it when you're ready to check the answer to the pattern. So hopefully you had a chance to go through the table and test all those out. And after a while, maybe you sensed the pattern and you didn't have to count after a while. And you notice that faces plus vertices minus edges equals 2. So as we go back in our notes, we can write that down under Euler's theorem, this is known as. So faces plus vertices equals edges plus 2. Or another way we wrote that was faces plus vertices minus edges equals 2. So now that we know that, we can use that and apply that with different ones. So see if you can find the number of faces, vertices, and edges in this regular octahedron. So go ahead and do that. Restart the video when you're ready. So in the octahedron, we have 8 triangular faces going around the top and the bottom. We have 6 vertices, 1 at the top, 4 along the side, and 1 at the bottom. And then 12 edges, 4 along the bottom, 4 along the middle, and 4 going to the point on the top. And 8 plus 16, 8 plus 6 is 14, minus 12 is 2. So Euler's theorem works for that one. So now let's take a look at cross sections. Cross sections are if we were to take a knife and slice through a figure, what would that shape be that we are slicing? So if we take this cube and slice it 3 different ways, notice if I slice it directly horizontally through the middle, we would get a square. And B, if we cut diagonally, notice we get a rectangle. And then if we were to cut now, kind of through the corner, if we cut partially through the middle, more than halfway here on either side and cut at an angle, notice that we get a trapezoid, an isosceles trapezoid here. So notice there's different cross sections that we can get depending on how we are cutting through a figure and how we are looking at it. And that's important as we take a look at, as I mentioned before, volume, as we try to calculate volume, and also as we're trying to manipulate a shape and see what we can fit inside a shape, the different shapes that can fit in a 3-dimensional figure. So now I'd like you to take some time to take a look at these figures and try and come up with two different cross sections as we look at them. So I'll show you a couple of these. They're in the classroom too, if you want to take a look at these when you're in class. But let's say we have the triangular prism. Notice we have a triangle up front and back. It's like we take the Play-Doh and stuff it through the triangular shaped hole. We're going to get a triangular prism as that goes through there. So think about the cross sections. Well, think about it if I look at it from the side. Now, what shape do we have there? Pretty apparent that you've got a rectangle is one of the cross sections that we have. The other one, if we look at it from the front, that's pretty obvious. That's that triangle. Then other ways we could envision it, well, what if we sliced, at an angle? What would that look like? I'll show you a GeoGebra app that can help us with that. Then do the same with the square pyramid. And what does that look like? And what cross sections do we have? Then also the sphere. And then the cone. As I mentioned before, you have the GeoGebra app on Classroom and the website. And there's multiple different cross sections that you can take a look at. So just make sure to turn off the 3D glasses unless you have 3D glasses. That'd be really cool. You can take a look at that. But let me see if I can find remember where that feature is. So yeah, if you've got 3D glasses, put them on. You can take a look at this. Otherwise, click this button and just change it to three-dimensional. But you can change the size. You can tilt the cross section. You can kind of see the cross section here in black. We can change the size of this pyramid. If we'd like, we can take a look at this. We can rotate our cross section and see what different kind of figures we can get, or cross sections we can get. So if we tilt it, we see, oh, we got a square or rectangle, and we can tilt that a little bit and get a quadrilateral. We can rotate those and see. So I'll let you take a look at that and play around with that as much as you like. With the pyramids, you can do the same with the prisms, and you can change with these prisms the number of sides. So get a square or rectangular prism, you can get a pentagonal or hexagonal. So you can do that with any of these and kind of see the cross sections that are there as you tilt and rotate. So go ahead and do that, and then list at least 2 different cross sections for those figures, and feel free to look at some of the other ones as well. So restart the video when you're ready to see just a few of the different cross sections. Okay, so I just picked some of the basic ones. If we have a square pyramid, if we look at it from the bottom or above, we've got a square. And if we look at it from the side, we've got a triangle. A sphere, well, that one's either circle, no matter how you slice through it. Big circle, little circle, medium circle. And then the cone, if I look at it from above or below, we see that's the circle, that's the base shape. On the side, we see that, hey, it fits. Here's my hat. Party hat. It's a triangle. So anyway, moving along. Let's also take a look now if we take a different shape, a two-dimensional shape, and if we rotate it, now we're going to do some visualizing. If we rotate it around an axis, what three-dimensional shape do we get? So for instance, if I were to take this rectangle, this Post-it pad, and I rotate it around in a circle, I rotate it around this point, notice I'm going to get a cylinder-shaped, a cylinder shape. So think of that as, let's say I've got your snow shovel, and you take that rectangle and you spin it around in a circle. You're going to have a cylinder-shaped space now where you've shoveled out the snow. So we want to think of shapes now in that sense. So think if I'm taking this rectangle, I'm going to rotate it around this axis. What three-dimensional shape will I get, and what will the dimensions be? Same with this triangle. So pause the video and restart it when you're ready to see the solution. Try sketching it on your own. All right, so if we take a look at what we have, if I rotate this rectangle, notice I've got that cylinder as it rotates around. You can kind of picture how that rotates. We've got that cylinder shape that remains with a radius 4, height 9. Same here with this triangle, it kind of rotates around, and we've got that cone shape with height 5, radius 2. Now let's finish up by doing the same thing, but see if you can calculate the volume. So pause the video, make a general sketch, and see if you can calculate the volume. All right, so as we take a look at this first one, it's rotating around, so we've got a cylinder as it rotates over. And this one, we've kind of got two cones as they rotate over. And as we take a look at that, we can see how we calculate the volumes of those. We'll talk about volume in a later lesson, so don't worry so much about that at this point, but this is kind of giving us a visualization, kind of how this works, kind of an introduction to volume. So if we take this rectangle and spin it around, it's got a height of 6, radius 5, we can calculate the volume accordingly. Like I said, we'll talk more volume in a later lesson. Same here. We got these triangles 2 by 3, which means 2 will be the radius as it rotates around because it's always a length of 2. Then it's a height of 3 on each cone. All right, so we got a big introduction on solid figures, three-dimensional figures. We talked about how to classify polyhedra. We found out Euler's theorem for faces, vertices, and edges. And we also got into rotating two-dimensional objects. So we got a lot in this lesson. You'll do some work in your practice.